Alright, so first problem from last biweekly contest, you need 3-digit even numbers. So I'm given a digits array and I'm told to find all distinct 3-digit even numbers that can be formed using these digits, and I can use each digit only once. So if there are some edge cases like 666, in that case I can use this 6 once, this 6 once, and this 6 once, eventually forming only 666. And the other 666 that I will be forming will be not distinct, so only one is possible, right? So 022 in this case, since there can be no leading zeros, there may not be no, any leading zeros, so 022 is not possible. 220 and 202 is the only possibility, and that's it. So these are the only edge cases. Since the constraints are very small, I'm going to use the very naive approach. I will have a unordered set here, and I will just iterate. Let me get digits.size. Here the first loop, since there can't be leading zeros, I will just check if digits of I is equal to 0. I'll continue. I will have the same loop here and the same loop here as well. This will be for j. If since I cannot reuse the digit, I will check if I is equal to j. I'll continue. I'll check. I'll have k. Pardon. This will be done here as well. If I is equal to k or j is equal to k, I'll continue. Otherwise, I'll insert the number. What will be the number? Number will be digits of I into 100 plus digits of j into 10 plus digits of k, but this will be only when the digit is a even number, and that will be happening when digits of k mod 2 is equal to 0. Alright, and I can return the set size, which will be my answer. Let's see if this works. It does. Let's move to the second question, design spreadsheet. I am given a spreadsheet, or I should create a data structure to store such spreadsheet, which will have 26 columns from A to Z and given number of rows. It can hold any value between 0 to 10 power 5. Initial value will be 0, and I'm given 3 functions: set cell, reset cell, and get value. So set cell will be given a string and a value. A string cell will indicate the cell reference, which will be of the format A, X. X can be multiple digits like 10, 11. It can be anything between the rows, and the column will be a single alphabet A to Z. And mind that this is a one indexed row, so there won't be any zero here in the value or the row section. And that's it. The reset cell will be of the same format as in the parameters, and it will reset the value to 0 for that particular cell. The get value will do the same thing, just that it has a formula in this time. With this format is equal to x plus y. X can be a cell reference, again multiple characters possible. Y, it can be a cell reference or it can be a non-negative integer, and that holds true for both x and y. And I want to return the natural sum that is possible. So there can't be any negative numbers, so there can't be any negative signs, and that's it. If get value doesn't have any value for that particular cell, in that case uh, it will be considered 0 because that's what the default value is set here. Alright, so straightforward problem. So what I can do is I can have a vector of vector. We just need to simulate it. There is no such efficient things or operations that we can do here, or at least it's not required. So I can have a grid which will be resized here to rows plus 1 because it's one indexed. So I have one extra space, so it's not going to affect anything. And column will be 26 in terms of size. Default value will be 0. I'm sorry, this should be vector of end. Alright, so now I'm setting the cell. This string cell should give me a row and a column, but I need to you know, get that, and I need to get that multiple times in formula cell and cell. So I'll create uh, a function which will return me row and column in the format pair, and I'll call it get row get column, get row column. This will be string cell. Alright, this will be basically of the format a x, right? So alphabet and then some x which has multiple digits. So what I can do is get cell of 0, and that will be my column. Cell of 0 minus a, all will be capital A's or alphabets, and that's it. That will be the column, and row will be initially 0. I'll get the index at 1, and I'll keep continuing the index as long as it exhausts the cell length. I will get the row in terms of row into 10 plus cell of index minus 0. This will give me the row, and I'll return it in a pair format of row and column, and I'll get that here row comma column, and this will be calling the row column function, get row column function, which will be having cell as the parameter, and I can just use the grid, get the default or the whatever value it holds. Oh, I don't need to return anything, it's just a set. So I'll just set it and return, and same thing here. This will be basically a 0 here in this case, that's it. And here the formula, this is interesting. This will be of the format alphabet or cell or value, and that is divided by a, we can call it a delimiter, if I'm not wrong, that's the spelling, which is in this case a plus, right? Because it's of the format is equal to x plus y, right? So what I can do is I can get the index of the delimiter, which will be formula dot find plus. Now I can just check, I can have values, right? I'll have two values, value 1, value 2. Initially let's say 0 and 0. If formula of 1, which indicates the first character of x, because I'm skipping the equal to, that's why I have skipped from 0 to 1. if it's greater than equal to A and formula of 1 is less than equal to z, in that case it's a cell. I will get the row and column like I did before, but this time I'll pass the substring starting from 1th index to how many characters just before index, right? Just before index delimiter, but the second parameter is usually the length, so I need to get the length. That will be nothing but what 1 from 1 I'm going till index delimiter. Let me call it index itself, right? So that I don't have to. Okay, so index minus so it will be basically index minus 1 plus 1. So it's essentially index minus 1 will be the length of the x string, and that will be basically value 1, which I can get using the grid and the row and column. If it is not true, then I need to get the value. What I can do is uh, I can create a get value, which is essentially taking a string, right? And I'll call it get value from string, and essentially I'm doing this exact thing, right? So I will uh, let's see, let me do this here. Let's have a value initially 0. Let's take the index. Let's iterate the index as long as the string is exhausted. I will get the value in this format, just that the cell will be string and the row will be value, and I will return the value here, and I can uh, do this instead, get value from string and pass the cell dot substring from 1 to from 1 till the entire thing. So this will give me the value, and that's it. I can reuse this function here as well, because value 1 will now be populated from this function with this substring. If I'm not mistaken, this substring should be it, and I can do the same exact thing or similar thing here. That will be, this time it will be after the delimiters index plus 1 plus 1, and the row and column will be from this substring of index plus 1 and the entirety, so I don't need to pass the second parameter. Value 1 will be this, otherwise value 1 will be this, and this will be value 2, by the way, not value 1. And that's pretty much it. I can return value 1 plus value 2, and that's it. I guess this should work. Okay, this should be substring get value from string Okay, let's see now. It seems to work. Let's submit it. Alright, this works. I don't know why it's super slow. But anyways, third problem, longest common prefix of case strings after removal. So we are given a strings words and an integer k, and for each index in the range this, I need to find the length of the longest common prefix from among any case strings selected at distinct indices from the remaining array after removing the ith element. Alright, so we need to return the answer where answer of I is the answer of the ith element. If removing the ith element leaves the array with fewer than case strings, then the answer of I is 0. We know what is a prefix and a substring. So what the question is stating is, let me get the pen out. We are given a, oh my god. Okay, so we are given words, and if I remove any word and then ask what's the longest common prefix that is present, which is in terms of count, it should be greater than equal to k, and if there are multiple, then I want the largest one, right? And if it is not possible, then return 0. So it's saying that if I have something like this, if I have jump 2 times, so it's giving me a length of 4, but how many times? 2 times. And then we have a run, it's giving me 3 length, but how many times? 3 times. And we want, this is length and this is k, and if k is 2 and this is 2, this both of them are valid, I need to return 4. But this is not it. We are told that we need to create an answer array, and we need to query every word such that we remove that from the array, hence not counting it, so that this will be the remaining. And now since the count becomes lesser in for jump, in that case run is the valid one, is the only valid one, and its length is 3. That's why 3 is the answer. Now when I move to second index or the second word, in that case jump is added back. It's independent in terms of queries, so it's present here, but this time I'm returning or removing 3 run. In this case, since run is removed, I will remove its count to 2, right? There are only 2 runs. In this case both are valid, so 4 will be the answer, and that's it. Similarly others, and that's how we are going to, that's the problem. If there is no such common prefix, then 0 is the answer, right? And we are told that sum of word of I dot length is smaller than or equal to 10 power 5. So this is something to note. And this problem, fairly, points towards try data structure, because that's how we can maintain it efficiently. But along with the try data structure, within that, there must be certain key field that will help us in the solving of this problem. And what is that feature? Let's see. So if I have something like, let's say, if I have jump, jumper, run, runner, something like this. In that case, if I build this data structure in a try, I will do it like this. right? This will be M, this will be E, this will be R, but this is done, this is done, this is done. I will have uh, a runner. Alright, so this is done, this is done. But I don't have a count, right? I don't know how many prefix is present, how many times. What I can do is, as I was creating every word, I will keep on adding it. So as I created jump, I added 1112 to every character, stating that this has happened only one time. And then next time I add jump, in that case this will become 2, 2, uh, 2, 1, right? When I added jumper, in that case this will become 3, 3, 3, 1, 1, 1. When I added run, this will be 1, 1, 1. When I added runner, this will become all 2, others will be 1, right? Now if I am told that I will be removing, I'll be creating an answer array, right? So I'll be removing one by one and see what's the answer that I'm getting, right? But the problem is, if I do this, if I do just this, in that case I will be basically traversing this, making it 2, and then traversing the entire tree to see what's the count, and among the count, whichever is greater than equal to k, I will get the maximum out of those. That will take a time complexity of O of n for every word and making it O of n square. And that's after building the array. Building the array or building the trie will be O of n log n. That's separate. But we can do better here, and we are very close to the answer here. So what basically we need to do is, we need to, before when we are building the trie, what we can do is we can create a map. And what should be the key of that map? Well, the key of that map will be uh, the length. That will be the key of the map. What we can do is, as I created jump or this entire structure, what I can do is I can store every count that is greater than equal to k. I'll store it inside my map of what? Integer. That will be the count length. And since this is a map, this will give me a sorted length of the entire trie structure, right? So whichever count is greater than equal to k, that will be added inside the map. This will be stored in sorted fashion. What should be the value? What should be the value? Since I'm storing a node, I can store the address, right? So this can be a trie node, a pointer to the trie node, right? But should it be just a trie node or a vector, or even better, a set of trie node? We can use a vector of trie node, but that will be basically, I will require to remove the trie node as I remove and add back the word when I'm querying the words in order to generate the answer. That's why I'm going to choose a set of trie nodes. This will be a unordered set of trie nodes which I will create when I'm building the when I'm first time building the trie itself, right? Now when I start building the answer, what I'll do, I'll remove the word, and then I'll see what's the largest. Since this is sorted, I can just O of 1 look up the largest length that we have here, and then When I'm moving to the next word, I'll add back this word and similarly update the map as well, right? So let's start building the tree first. We'll have a try node, or let me call it just try. First thing will be the field, the typical field that we have. I'm sorry, this should be map character 2 or try. This we call it children, and I'll have a count, and this count is basically this count that we have for every try node, and the default value not here. In the constructor we'll have it as count to 0, and then I will have a add word, which is essentially taking a uh, anyways, since we have this as a function inside the class, so I don't need to pass the root. I'll pass the word, this needs to be added, and I'll pass the map in which we'll be updating things, which will be a map of int comma unordered set of what try pointer, which will be passed by reference, and let me call it map. Here we are going to start doing that we needed to do. I'll first get uh, the pointer, and then I'll start traversing the word that we need to add. Let me get a character which I'll be using. So if the root of children uh, dot find, if it's not present in the map, what is not present? Character minus a, or I can just store the character itself, so that yeah, I can just do this. If it's not present inside the map, in that case I am going to create a new try and give it to this child, and I'm going to move the root pointer to that child, and meanwhile, since I have visited this child, I'll increment the count, and I'll check if this increment is greater than equal to k. In that case, I'll be updating the map. What's the length in the current scenario? What's the length of the string that we have encountered, or the prefix that we have encountered? It's map of I plus 1 because that's the index, plus 1 because this is 0th index, that's why we need the length. And I'm going to insert this particular root as the value inside the set. And that's it. I can return. Now comes the remove word function, which will again take a word that we need to remove and the map, and I'll get the pointer. I will do the same exact thing. So let me copy this here, but this time I'm not going to create any root child, right? I'm going to go to that children. I'll keep iterating forward This time I'll reduce the count and I'll check if the reduction before the reduction, that was root of count plus 1, if it's equal to k, before the reduction if it was equal to k, in that case I will erase this root and check if this erasure is going to make the size of the set to 0. If it does, then I'm going to erase the length as well, so that it's not going to affect our answer, right? This will be basically I plus 1 is the length that we need to erase, and that's it. That's all we need to do. We can return and we can start our main function, which will be basically creating a try node or the try structure. I will have a map, so let me copy this down. I will iterate through the words. For every word I am going to add it to the try, passing the word and the map. I will have a vector of int, because next thing is we are starting to build the answer, which will be of size words dot size, having default values as 0. I will start iterating. You know what, let me just get the word from the words, or actually let me enumerate actually words dot size. Alright, so the root remove word function will be called for every word, and the map will be updated. At this point, if the map is empty, in that case I can just add back the word and continue. uh, right, add back the word. What that was, words of I, words of I. The map will be updated back and I will continue. Else I'll be here and I will update the answer based on the map, and this time, since this is sorted, I will get the last length, the largest length that we have, and update it. I'm sorry, there should be first, not length, and then update back the word. Alright, so technically I can do something better here. By the way, I missed something. This should also be passed here. It should be passed here and here and here. Alright, and here as well. What I can do better is, what I'm thinking is, if it is not empty, if the map is not empty, that means in the map I have some length which is greater than equal to k, right? Because in the map I'm always having only the lengths which are greater than equal to k. So if it is not empty, what I can do is take this outside, update the answer if it is not empty, and then add back the word. So this is better. Alright, and that's it. We can return the answer here. Let's see if this works. Okay, my bad, this should also have k, and that's it. Okay, this is words of I, not word of I. This is words of I. Oh, oh, this is word of I, which is right. Oh, this should be I less than word dot length. I less than word dot length. Let's see now. Seems to work. Let's submit it. Alright, so this works. The time complexity will be the add word will be basically traversing all the words, right? Because I'm calling it for all the words, and that will be taking a time complexity of O of n into m, where m will be the length of the of each word. The remove word will work on the time complexity of O of n into m log n, because I'm calling it for every word, and I'm also adding it back, by the way, but still it will be on in some time complexity of O of n into m log n, and the map will also, since this is sorted, that will also be in the same time complexity range. So that will be the dominant factor, O of n into m log n, and yeah, that's the fourth problem. Thanks.